Oh, hey, what's up, everybody? We're going to continue some graphing. All right, so we have a rational function that we need to graph and get some pieces of information for. So some of this is going to look like 12a, where we have mapping notations and horizontal translations and vertical stretches and things of that nature. Okay, those things are going to remain the same, but the types of graphs that we have are going to look a little different. So just recall from the previous video, all right, we looked at what the basic rational function y is equal to 1 over x looks like. It comes in two pieces with your horizontal and vertical asymptotes along the x and y axis, and your two key points of 1, 1 and -1, -1. All right, so we're going to shift this around and we're going to stretch it and reflect it. So, of course, whenever you have transformations, you want to, first of all, get the mapping notation. So what comes after the x gets changed. So we go to x plus 4 instead of x minus 4. No number in front of the x to flip over, which will usually be the case here. So we'll just leave alone any horizontal stretches. And the y values remain the same. We do not change those. So we have a vertical stretch of 2. There is no reflection because there's no negatives in front of the x or y. And we have a horizontal translation and we have a vertical translation. And let's just remind ourselves that those horizontal and vertical translations actually show up as asymptotes. So let's think about how the vertical asymptote was once the y-axis. Okay, if we have a horizontal translation of 4, what that will do is that will shift our vertical asymptote to the right 4 units. So we now have a vertical asymptote right in here at x is equal to 4. Okay, so we've actually found our vertical asymptote, x is equal to 4, and our vertical asymptote comes from our horizontal translation. So you might say, okay, well, horizontal, vertical, what's the deal with that? Why are they both the same? It's a vertical line, but you're shifting it horizontally. You're taking that vertical line and you're shifting it 4 units to the right. So that's a horizontal translation of a vertical line. And similarly, okay, we do a vertical translation of a horizontal line. The original horizontal asymptote was once the x-axis. We now shift that down 3 units, so we have our new horizontal asymptote at y is equal to -3. Okay, so we have our horizontal asymptote, we have our vertical asymptote, which comes from the translation numbers in the mapping notation. Okay, so that's a great start. All right, now that we have that information, okay, we can get the KPs, which are the key points. So let's remind ourselves that the two original key points are 1, 1 and -1, -1. And when we put those points into our mapping notation one by one, you're going to wind up with these numbers right here. These are the new KPs, which are known as key points, and we should plot those on our graph. Okay, so we've now discovered what the key points are using the mapping notation and the two original key points. So we have one at 5, -1, and we have another one at 3, -5. And with those key points and the asymptotes, we're pretty much good to go. But maybe we can get some x and y intercepts too. I would hold off on domain and range until you have your graph completely drawn. So why don't we go to the next slide and calculate the intercepts, which you are going to do by plugging in 0 for x and 0 for y. So this is strictly algebra. You're going to get some decimal numbers here. For example, here we get 2 over -4. That's going to be equal to -0.5 minus 3, which is -3.5. Or you can write it as a coordinate point of 0, -3.5. That is our y-intercept. So you can go back and put that on the graph at -3.5. We have found a y-intercept. So I'm going to put that in here somewhere, and that's going to allow me to sketch this graph just a little bit better. Okay, what about the x-intercept? All right, we put in x-intercept, we put in y for 0, 0 for y, sorry. This is a little harder to solve. We have to solve for x on the denominator. You can start by bringing that 3 over. That -3 becomes a +3. And then at this point, you can do some cross multiplication. So I can put that 3 over 1, and I can cross multiply 3 times x minus 4 is equal to 2 times 1, which is 2. And then I can just solve for x from here, just some basic algebra. We end up with x is equal to 14 over 3, which is approximately 4.67, and we can express that as a coordinate point. 2 decimal places is fine for these. I didn't really specify how many decimals, so if you use more or less, I would go with at least 2 decimals. All right, so we have our y-intercept of 4.67, and you can put that on the graph, estimate it, and then that allows us to sketch our graph a little bit better. The curves always have to approach the asymptotes, so we get something like that. We have our intercepts completed. The very last thing we need to do is domain and range. Once again, you can write it the old way and say what x and y cannot equal to. Or since we're in the new way of doing things, why don't we just stick with this? We can say that the domain here goes from negative infinity to positive 4, and then again from positive 4 to positive infinity. That's basically saying that the domain is all values of x except for positive 4, and likewise for the range for y, it's going to be everything except for negative 3. And there we have it. We have our domain and range, key points, intercepts, asymptotes, and most importantly, we have our graph drawn.